Okay. Uh, let's use Euclid's algorithm, Euclid's division lemma, that is, to show that the square of any positive integer is either of the form 3m or 3m plus 1. What are we trying to show? Show that square of any positive integer is either 3m or 3m plus 1, where of course m is some integer. Okay. Now let x be any positive integer. Okay. Let x be any positive integer. Okay. Uh, then that means that x is of what form? X is of form 3q or 3q plus 1 or 3q plus 2. Okay. Now then what do we have to prove actually? Now then we have to prove that each of these, okay, square of these is of the form 3m or 3m plus 1. So let's look at 3q whole square. 3q whole square is equal to 9q square. 9q square, and that can be broken up as 3 into 3q square. So this is equal to 3m, where m is equal to 3q square. Then if I say m is 3q square, then this 3q whole square is equal to 3m. So we've proven that. Now next let's look at 3q plus 1 whole square. Now 3q plus 1 whole square is 9q square plus 6q plus 1. So that equals to 3 into q square plus 6q plus 1. Sorry, 2q. 3 is common, so 2q plus 1, and this equals to 3 m plus 1, where m is q square plus 2q. Okay. So we have proven that the 3q plus 1 whole square actually it equals to 3m plus 1. Now similarly you can also prove for 3q plus 2 whole square. Now when you open up that, you would get 9q square plus 12q plus 4, which would equal to, thrice again taking 3 out common, you would get 3q square plus 4q plus 1. Now breaking this 4 into 4 is what? 3 plus 1. So what we've done is just broken up 4 into 3 plus 1. So when you take out 3 common, you would have 1 inside and 1 comes out there. So this is also of the form 3m plus 1, where m is equal to 3q square plus 4q plus 1.